Let's review ionic formula writing. We need to talk about terminology because I think that's just what's keeping you from really getting this concept. So on the right here, this is called a chemical formula. Okay, so it's a formula of a compound. We know it's an ionic compound because we have a metal, aluminum, with a non-metal, oxygen, right? These little numbers underneath the normal line of writing, those are subscripts. Okay, and what the subscripts tell us is how many of each atom or ion, in this case it's ions, that we have. Okay, and that should sound familiar to you because we're doing balancing and the subscripts come into play there too, as well as coefficients, big numbers out in front. We're going to ignore those for this tutorial. Now let's look over on the right side. Okay, these are the actual ions that make up the ionic compound. Okay, notice that the ionic compound itself has no charge. And that's because it's a neutral charge, right? The charges have canceled to make this an overall no charge compound. So here we have the individual ions. These numbers up here are charges. Okay, so aluminum has a +3 charge. Oxide ion has a -2 charge. You can look those up on your periodic table that's labeled with the charges. Okay, so when I say write the charges, you're doing this. When I say write the formula, you're figuring out how to write this, right? So a shortcut is called the cross-down method. You don't have to use this, but it will work. Okay, and then I'll show you why it works. So cross-down method, we're taking the value of the charge from your negative ion and you're making it the subscript for the metal, okay? So that's going to give us Al2. I have a lot of you writing Al -2, okay? You will never see charges in a formula, never, okay? So don't be doing that. You can't have -2 of something. So Al2, and then look at this value here, just the number, that's a 3. So that's going to go outside of oxygen, so O3. So Al2O3, notice that's what we have up here as well. Here's why it works, okay? We have 2 Als. Each Al had a 3+ charge. Okay, if you add that up, you get yourself a +6. We had 3 oxide ions. Each oxide had a -2. Okay, we have 3 of them. So -2 plus -2 plus -2, that gives us a -6. Well, when you take a +6 and a -6 and add them together, you get a 0. So that's why this is a neutral compound. Okay, so moving on. You need to have your periodic table out and your pink sheet. Don't try to just write the formulas. First, you have to do your ions. So for every single one of these, I want step 1, which is your ions, and then step 2, which is your formula. Okay, so we're only working on step 1 right now. So sodium is Na. Look it up on your periodic table. It always has a +1 charge. Okay, nitride. Some of you are going right to your pink sheet and you're not going to find it. IDE means it comes from the periodic table. It's just a non-metal. So look on the right side of your periodic table. It's nitrogen, N, right, with a -3 or 3- charge. So now I've fulfilled writing my ions. Next step is to make the charges cancel. Okay, so if you look right here, a +1 and a -3, they do not cancel. So that means we can use cross down to figure out how we can make them cancel. This 3 is going to come down here. So we have Na, 3 of them, and then N, 1 of them. Okay, now we don't usually write the 1. So just Na3N, 3 sodiums, 1 nitrogen. If you have 3 +1s, that's +1 plus +1 plus +1, that's going to give you +3. That's going to cancel out your -3. Okay, let's look down here. This is sodium nitrate. So good news, you're going to have the same cation. Cation is your positive one, but this is a different anion, right? You had nitride, this is nitrate. So nitrate is a polyatomic ion, meaning a group of atoms with a charge. That's what's listed on your pink sheet. So look up nitrate, okay? NO3 with a -1 charge. I'm seeing what I'm about to do is wrong. I'm seeing some of this, I'm seeing some NO3, and then you don't write the charge. Or I'm seeing some NO and you write a -1. Neither of these is nitrate, okay? You have to have NO3 and a -1 for it to represent nitrate. Let me just write NO3 -1 up here again. All right, now we got some good news. +1, -1, do they already cancel? And the answer is yes. So in this case, we just need one of each thing. So NaNO3. This 3 doesn't mean that there are 3 nitrates, right? This 3 is just part of nitrate. It's like a nitrogen parent and 3 oxygen children. So if you change this 3, you're kidnapping oxygen children, and you don't want to do that. You should not kidnap anything. Let's move up here. Iron 3 sulfate. Okay, let's write our ions first. So iron is Fe, and if you look at your periodic table to find its charge, you're going to notice it's in this section that varies, right? Look what I give you. This Roman numeral tells you the charge of iron, okay? It tells you the charge of iron. So it's plus Roman numeral 3 plus 3, okay? If you have a metal where the charge varies, I have to tell it to you in the charge in the name, like I did here in the Roman numerals, okay? Sulfate. Sulfate is on your periodic table. Sulfate is on your pink sheet, so look up sulfate. SO4 with a -2 charge, okay? That's step 1. Now we're ready for step 2, which is to cross it down, okay? Just check, does a +3 and a -2 cancel? They do not. So this 2 is going to become the subscript of iron. This 3 is going to become the subscript of sulfate. So you still have to write the entire sulfate, SO4, okay? And then with a subscript of 3. Now, when you have more than one polyatomic ion, you have to put it in parentheses with the subscript outside. So we read this Fe2SO4 taken 3 times, right? Here, you don't need parentheses because you only have one of the polyatomic ion. You only have one nitrate, one NO3. All right, our last one. Oh, it's iron again. Okay, so is it going to be exactly the same as it was up here? No, because here we had iron 3. Now we have iron 2. That 2 is the charge of the iron. Some of you, I'm going to do this and it's wrong. Some of you say, oh, Fe, there's a 2 here. That means I put a 2 here. No, you don't. That's wrong. Okay. Fe with a +2 charge. Then we have hydroxide. Now, normally IDE means it's just a nonmetal from the periodic table, but there's no hydroxygen. So instead, you're going to look on your pink sheet, and if you scan down, alphabetical order, you're going to see hydroxide. It's 1O, 1H with a -1 charge. Okay, that is a polyatomic ion, hydroxide. All right, we got a +2 and a -1, so they don't automatically cancel. So let's do this. The 1 is going to come down here and become the subscript of iron, but we don't really write the 1. And then this 2 is going to become the subscript of the hydroxide. So be careful. I see a lot of this. Okay, that's not perfect. Hydroxide is a polyatomic ion, so you must put it in parentheses with the number that you need outside the parentheses. So that's FeOH taken twice. Please notice, you will never see charges in formulas. You will never see Roman numerals in formulas, okay? You'll see Roman numerals in the name, but never in formulas. You'll see charges as part of your scratch work, but never in formulas, okay? So we have to cross these out big time because you'll never, ever see stuff like this. Okay, now you're going to practice on your own. So copy down these 4 names, Okay, and for each one, you're going to do step 1, which is write the ions, okay, the charges. And then step 2 is write your final answer, your formula, where the charges cancel and you have an overall neutral formula for a compound. Okay, good luck. Take your time. You're using your periodic table and your pink sheet.